Learning Outcome 9.6. Determine the stability and causality of a system based on the ROC and relate this to the corresponding impulse response. This learning outcome in this video have a worksheet that's connected to it called lo96worksheet.pdf. Look for that in Blackboard or on the website and then print it out. All the discussion in this video depends on that. Please pause this video and return once you have the worksheet. The rest of the discussion will not make sense without it. I presume you have the worksheet in front of you. If you take a look at it, each quadrant has a very similar format, but the functions are different in each. Please look at those 4 functions. You can see that they have a lot of similarity to them. I want you to now take the worksheet and start by graphing that function versus time in the place provided for it. Then, think back to the rules from Chapter 2 and determine the causality and stability of the system based on that impulse response h of t. Rewatch video for LO24 if you don't remember how to do this. I hope you do remember. It wasn't that long ago. Please pause this video and return once you've completed this part of the worksheet. The discussion depends on you doing this. Now we're going to move on to the Laplace transform part of the worksheet. In Learning Outcome 9.2 and 9.4, we talked about finding the transform h of s. You may use Table 9.2. Please determine what h of s would be for each of these h of t. Associated with it will be an ROC in the last column of the Table 9.2. For each of your h of t, please determine h of s and the corresponding ROC. Then, based on the ROC, please graph it on the provided axes. If you don't remember how to do this, please look at the video for Learning Outcome 9.4. Again, please pause this video and return once you've completed this part of the worksheet. I presume if you're watching right here, you've now completed the worksheet. We're going to discuss its results. Based on your work, which h of t are causal? Which quadrants? Which of the 4 functions? Now look at the ROCs for the causal h of t. Look at your pictures for the ROCs which are causal. What do they have in common? Look for a pattern. Now stability. Look at your results on stability. Which h of t are stable? Now look at the corresponding ROC pictures. What do the ROCs for the stable h of t have in common? Look for a pattern. Now I'm going to give you 2 definitions. Hopefully, based on the previous work, these make some sense. A system is causal if and only if its ROC includes positive infinity. That means the ROC should extend to the right. A system is stable if and only if its ROC includes the j omega axes. That's this axes right here, the imaginary axes. Does this make sense based on the results you have from working on the worksheet? Ask me if it doesn't. I'll be happy to discuss this with you. Now, if you've taken a systems class or a controls class, I want you to look at the example in this lower left corner. If you have not taken such a class, you can end here. It's okay. Or you can just listen. But this is designed to broaden the knowledge of students who've had some background in systems or control. So based on this example here, look at your H of S and determine what the poles are for this H of S. For what values of S is the denominator 0? Put an X in your plot for those pole values. Now let's look at your stability answer. Does the answer you gave on this worksheet contradict what you learned about pole placement and stability in your controls class? On the surface, it should look like it contradicts. But now I want you to take a look at the causality that you determined for this system. This system is not causal. Everything you learned in your controls class was for a causal system. Therefore, you will never have this situation in that controls class. For systems that are causal, if your pole is in the left-hand plane, your ROC will continue towards plus infinity and therefore must pass through the imaginary axes in order to get to positive infinity. So, if it's causal and your pole is in the left-hand plane, therefore you're sure it's going to be stable. Think about it. Again, I'm happy to answer your questions. If you have not taken controls yet and you've continued watching this video, don't worry if this last discussion didn't make sense. Just make sure you have all the earlier discussions clear and these two definitions.